let Jay get in. He's been in the waiting room since like 4 minutes.
Yeah, well, it kept saying he was joining. Let me, kept saying he was joining. It's taking an extremely long time. Yeah,
Right.
he might have got caught.
Yeah, he texted me and said
He might have gotten caught in La La Land.
couldn't get in.
Okay. Still saying that it's joining. I wonder if it might be something on his end. Because I said it's been showing him joining for 3 minutes, 4 minutes, which is unusual. If you're texting him, he's text there. Looks like he may have made it. Yeah, he made it this time. Okay. We're going to get going. Welcome to D period Algebra 2. It's Monday, April 11th. After today, we got 3 more classes together. One on Wednesday and next week, and then that's it. That's all she wrote. Hope everybody's doing well. Plan of attack is I'm going to post the answer key since it's hard to write with my mouse for the problem set that we were working on last Wednesday. Let you look at it. I know the vast majority of you did put it in Dropbox last week, so I've got you down. If you did it in the last day or two, I probably don't have it updated yet, but I will immediately after class is over. So I'll let you, we had done like the first 6 problems together. And so you were just supposed to do like 7 through 15. I think there was 8 problems. Let me find it. Let's take a look at it. Let's see. So we're operating with operations with radicals, and we're basically simplifying them. We're not really solving them per se. Let's see. We did 1, 2, 3 in class. So I'm just going to kind of run through them and let you look. I've got them blown up a little bit just because my handwriting was I was doing some of this in the car, so it's a little sketchy. So take a look at, I think we actually take a look at 4 and 6 because I got 5 checked off that we did that class, but just check 3 through 6, and then I'll just let you look at them. I'm not going to say much, and then ask questions, particularly if you got something totally different than what I got. Maybe to get us kind of get us in the thinking process. Let's look at number 6. So here you're distributing this 2 radical 3 with everything in parentheses. So if we multiply this times this, you end up with, since there's nothing written there's a 1 in front of that square root of 15, and the 3 under the radical and 15 under the radical multiplied. So you got 2 radical 45 for the first deal. And then we multiply 2 radical 3 times radical 60, so you have 2 radical 180, right? And all I did here to get from here to this line is 45 is 9 times 5, right? So the 9 is a nice perfect square. That comes out as 3, and the 3 times 2 gives us the 6, and the 5 stays under the radical. Let's see. Let me move us out of the way here. So I got pictures.
Can you go back to the first 2 answers?
I'm sorry?
Can you go back to the first 2 answers?
Yeah, just give me a second. And then
Okay, thank you.
Since I got a radical 5 here, I was going to see if there was some kind of perfect square involving a radical 5, and so I arbitrarily, not semi-arbitrarily, picked 5, and I divided it into 180, and lo and behold, it gave me a 36. We love 36 because that's 6 squared, right? So 36 comes out front of the radical as 6, and 6 times 2 is 12. So now I've got 6 radical 5 plus 12 radical 5, and then those two, since those are considered like radical expressions or like terms, I can add those together for a final answer of 18 radical 5. I'll let you look for a minute, and let me scroll back up to numbers 1 and 2. There's one that asked. Okay. Second. There's 1 and 2. And I'll do a quick little kind of talk through. All right, so 20 is the same as 4 times 5, right? So the 4 can come out from the radical as a 2, and 5 stays underneath the radical. 125 is the same as 25 times 5. So the 25, square root of 25 comes out from the radical as 5 and leaves a radical 5 under the radical. 45 times 9 we just used is I don't know what that's doing. That should be is oh, that's kind of messed up. There should be 9 radical all underneath there. I see what I did. 9 times 5, right? So the 9 comes out from the radical as a 3. So now I've got three like terms here. They all have the same value under the radical. So 2 plus 5 is 7, minus 3 is 4, and there's your final answer. All right, we good there? All right, so we looked at those 3. Now, we'll just go right up to there. Okay. Our work's a little messy there. So take a look at 7, 8, 9, and 10, applying the same, actually 7, 8, 9 were all foiled, right? They were all foiled. See? And if I'm going to walk through one, I'll be glad to walk through one of those with you. Otherwise, I
I possibly see 8.
want to see 8 worked out.
Yeah.
Okay, let's see here. I'm trying to figure out where can I. Let's do this. Give me a second here. See, let me shrink this down so I've got some working room. There we go. If I write over here, can you see me making circles? Can you see that over to the right?
Yeah.
Okay, so here's
Yeah.
great. I'll do it right over here. All right. All right. Let me clean up. I just want to make sure you can see the right part of the screen. Okay, so we're foiling. So we got 6 radical 3 times 3 radical 3, right? There's a couple of ways you can look at it. 6 times 3 is 18, right?
Yes, sir.
Now radical 3 times radical 3 is equal to 3, all right? Or 9 under the radical, all right? Which is also equal to 3. And the 18 times 3 is equal to 54. So I'm going to kind of do 2 things simultaneously. So I can simplify that 18 radical 9 to 54, right? Because the 9 comes out front of the radicals as 3, and we just multiply the 3 times the 18 for 54. All right, so that takes care of the first guy. This next one is 6 radical 3 times radical 2. So that equates to, let's see here, 6 radical 6, right?
Yep.
I can't simplify that any more than what it already is right at the moment. All right. Now I've got to distribute this. So I got negative 4 radical 2 times 3 radical 3. So I've got negative 12. What's that come out to? Got so much spread there. Negative 12 radical 6, right?
Yes, sir.
And I got negative 4 radical 2 times 2 radical 2, which is negative 4 radical 4. I'm going to have to write it up here because I don't know if it's coming off your screen, but it's coming off of mine. So I got negative 4 radical 4, which I can actually simplify. The negative radical 4 becomes 2, right? And I multiply it times a negative 4. So it's actually minus 8, right? All right, so I already simplified this 54. And I've got 6 radical 6 minus 12 radical 6. So I'm just going to start combining like terms. So I got a negative 6 radical 6. All right. So right. Yeah, negative 6 radical 6. think I may have the wrong answer there. -8. So 54 and 8 are like terms, so that becomes, I'm getting a totally different answer. Let me check my other answer key. So I should be 50. Scratch that out. Let me do this. So 54 -8 is 46, right? Oops.
Yeah.
So it should be 46 -6 radical 6, I believe. But let me double check. Let me double check, see, since I got two different answers here. Let's see. So make sure. What did you guys get? Yeah, it's 46 -6 radical 6, so that is an error. It's 46 -6 radical 6. So since I shrunk it down, you can also see 9, 10, 11, and 12. Any questions or anything I can address on those? All right, let me point out a couple things. On 10, there's a couple different ways you can solve this. What I did is I simplified what was under the radical before I went further. And then remember, we cannot have any can't have any radicals in the denominator. So we multiplied the denominator times itself, which is going to make that thing go away, right? Because 5 times 5 is 25, and radical 3 times radical 3 is radical 9, or the square root of 9, which equals 3. So that comes out from under the radical as a 3. So 5 times 5 is 25, and then times 3 is 75. The actual final answer is way over here. It actually simplifies all the way down to 5. Number 12, I didn't show you the work. I showed you the setup. I didn't show you the steps. It's like you got to FOIL the numerator and you got to FOIL the denominator. And remember that this is that complex conjugates rule or property. And anytime I've got a 1 plus 2 radical 3 and 1 minus 2 radical 3, my O and I are going to automatically cancel out. So the only thing I really have left to do is my F and L. If you know that, you can cut your workload down a little bit by kind of skipping the O and I steps, because they're going to zero each other out. Any questions on those? All right, so we got 25 minutes left. What I would like to do is to post up problem set 3, and we're just going to talk through some of them collectively. I'm going to let you do a couple, and I'm going to talk you through some of them collectively and prep you for a quiz in that you can do between now and let's say 9 o'clock on Wednesday morning, so I can grade it. It's only going to be like 14 problems. I want to walk you through and work out any kinks or bugs. I want you to do I want you to try a couple of them first, and just make sure we've got all the bugs worked out. And that's kind of the plan for the next 20 minutes or so. Does that make sense?
Yes, sir.
So I got to come out of share.
Sir.
Can I use the restroom real quick, sir?
Yes, sir. 65, number 3. Okay, so the quiz will look like this, but almost not quite cut in half. I think it's 14 problems instead of 22. So I want you to take a minute each to do number 1 and 2, and then we'll talk about them. Okay, take a minute to do 1 and 2, and then we'll talk about them. You don't need to go any further. You can, as long as you know. As long as you're confident with what you're doing, okay? And just handwrite them on loose leaf paper. I'm not going to have you put them in Dropbox. And this is just kind of practice, warm up. Again, just to prep for the quiz. And you could, hopefully you guys still have that little 4x4 sheet of perfect squares and perfect square roots. I think it had perfect cubes and perfect cube roots on it, okay? Everybody looked at 1 and 2? So I'm hoping your thought process is 24 can be multipliers of 24 are 4 and 6, right? And we love 4 because that's a perfect square, right? So that comes out from under the radical as a 2, and the 6 stays under the radical. Again, we're simplifying, we're not solving. That's all the farther I take it. Just like 75 is 3 times 25. So we love these 4s, 9s, 16s, 25s, 36, 49s, and so on. So that's 3 times 25, right? You can have a little kind of reference guide there. So the 25 comes out from under the radical as a 5, right? Excuse me. And it leaves 3 under the radical. All right, so that's easy money. Make sure you know it. If you're struggling on those, let's make sure we get those correct. All right, now let's look at 3 and 4. A couple things I want you to watch out for is number 3 is a cube root and number 4 is the 4th root. All right, on these large ones, particularly like on 48, what you may want to start doing, since that is an even number, is let's see how many multiples of 2 we can get out of there. I'll just start it. I'm going to let you go from there. All right, that's 2 times 24, right? So you try 3 and 6, or 3 and 4, I'm sorry, and then we'll talk about those. Ready? I'm going to rush you, but. All right, when I look at 16, what jumps out at me is 16 is 8 times 2. And if you look on your little guide there, 8 is the cube, is 2 cubed, right? So 8 comes out from under the radical as 2, and we still have 2 under the radical. Does that make sense? Now, likewise with 48, I think we ended up, if we do this all the way down, we got 224, we have 212, we got 26, we got 23, hopefully. That's what you came up with, right? And what's perfect is I got 4 2s right here. We're doing to the 4th root, right? So those 4 2s come out from under the radical. The negative just rides along for the ride, right? And we still have 3 under the radical I can't do anything with as a cube root. So it should be -2 4th root of radical 3. Questions on those?
Mr. Gaffney, what happens to the, like, number 3? What happens to the 3 in front of the radical?
Yep, my error. Just so we didn't confuse it, that it was a square root. That should be right there. Should be right there. Okay. Any questions? All right. Let me. Are we getting the answers? Clicking? I'm hoping it's clicking, starting to click right now. All right, let me do 5 for you, and then I'm gonna let you do number 6, all right? So there's that 50. So the first thing that jumps out of me is 50 is 2 times 25, right? So the 25 we like, because that's 5 squared. So the 5 comes out from another radical and is multiplied times the 4. So now I've got 20 outside the radical, right? So I've addressed the 4, I've addressed the 50. Now I've got left is x to the 5th, right? Well, that's the same thing as x squared times x, right? So the x squared comes out as x. The other x squared comes out as x. Or x squared times x squared. It's kind of like x squared squared comes out as x squared, right? I know I'm kind of redundant. And there's still one single x that's still under the radical. Does that make sense? Okay, now you try number 6. Pay attention, it's to the 4th root. All right, you try 6. You got a question, holler it out. Okay, so hopefully you did this. So I've got 4 2s right here, right? And a 4 left over. So the 64 could come out as 2, and I still have a 4 under the radical, right? I can't do anything with. If I had an 8 under the radical, I could bring that out as a 2. I got 8 to the 4th. So 8 to the 4th is a times a times a times a. I love that because it's a multiple of 4, so it comes out as a. And likewise, b, applying the same property, just comes out as b. So it should be 2ab radical 4. All right, let's skip 7. All right, I want you to try 8. And what may make things simpler is to do this. It may, things may jump out at you to solve these if it's written like this. You can do, I mean, r squared t there too. All right. So give that a try. I'm going to give you a minute or so. Okay, so the 25 should come out from the radical as 5, right? Take care of that. The 36 comes out from under the radical as 6. That's great. The r squared, since this is a square root, comes out as r, right? Because that's r times r. Or the square root of r squared is r, another way to look at it. And the t, I cannot simplify any further, stays under the radical. So it should be 5/6 r radical t. Everybody get that? All right, see some heads nodding. That's good. That's good. We good? All right. Take this a little bit. All right. You may want to also rewrite this as negative radical 3 over radical 7, right? Remember the golden rule, I don't know who made it, but it's the rule, is no radicals in the denominator. So how do we fix that? We multiply it times itself. And kind of like equation, what I do to the left side, I got to do the right side. Well, what I do to the numerator, I got to do to the denominator, all right? So radical 7 times radical 7 is radical 49, or itself times itself is going to be itself. So that's 7 on the bottom and 21 under the radical on the top. And I'll put the negative sign right there. So there's your final answer. Does that make sense?
Yes.
Okay.
Yes, sir.
This is a good little bonus problem because it's got a little trickery with it, right? So we got cube root, right? What is 9 to you? Tell me something about 9.
It's the square for 3.
It's a square for 3. Okay. So remember the golden rule is I can't have a radical in the bottom. So how do I get rid of, what do I multiply by? It's a little different. What do I multiply by since it's cube root to get rid of that radical in the denominator? Good question. It's a good question. This is a thinking one here. What do I need to make 9 what do I need to do to make 9 a perfect cube instead of a perfect square?
-3.
There you go. Well, not so much -3. That is the right answer. I'm going to multiply both sides by 3.
All right.
Because I'm sorry, this is still cubed here. I can't write little 3s with a keypad. All right. So now my answer is actually going to be cube root of 6. All right, 3 times 2. Cube root of 6 over 9 times 3, cube root of 27, which comes out from under the radical as 3 because 27 is 3 cubed, right? So there's your final answer. That one you had to think about a little bit. Don't just kind of blindly, because I think most people are probably going to want to multiply times both the numerator and the denominator by radical 9. That make sense?
Yes, sir.
All right. Any questions before I move to the backside? We getting these answers, hopefully? Yes, yes.
Yes, sir.
Okay. Let's see here. All right. So I'm not gonna have you do 11. You can do 11, but you'd multiply both the numerator and denominator by 5z, or radical 5z. I'm sorry. All right. How about I want you to try 12, and you're just multiplying this guy times this guy. I'm going to give you a minute or two. Tell me what you come up with. And it might not be the answer you would think it would be. All right, let's see, where was I? So what did we come up with? Anybody? Hopefully we got this. Right? Did I get that? See a couple heads going up and down. Because the 3 times 15, 3 times 5 is 15, right? Radical 3 times radical 3 is radical 9 or 3. So it's 15 times 3, right? All right. I'm gonna skip to, let's go to number 14. Try number 14. I'll give you a couple minutes. What you want to do, now we're adding, so we got to have like radical expressions, like terms, right? So the approach on this should be to simplify. We can't simplify radical 2. That's as simple as it's going to get. But we can simplify radical 8 and radical 50. And what I mean by that is you can bring some of those nice perfect squares out from underneath that radical. And hopefully you will have some like radical expressions or like terms. So approach it that way. Okay, so we should end up with radical 2 plus 2 radical 2 plus 5 radical 2, which 7, 8 is 8 radical 2, right? Everybody get that? All right. Now let's skip over here to number 13. Now we could multiply the 4 times the 3 and get 12, and the 12 times the 20 and get what? What's that? 240? You could do that, or you may want to simplify these expressions before you do that, and that keeps the numbers a little bit smaller. So 12 is 4 times 3, right? So the 4, we like the 4 because it can come out from another radical as 2. So this now can be simplified to 8 radical 3, right? That's 8 radical 3, even though it doesn't look like it. And then this 20 is 4 times 5, right? There's that 4 again, which we love, which can come out for another radical as a 2. So now I've got 6 radical 5. All right. So let's see. 6 times 8 is 48, right? And we got 3 times 5, which is 15 under the radical. Now, that's one way to do it. Again, that keeps the numbers you're working with somewhat smaller. When they're smaller, you're less likely to make a careless error. Or you could do it the long way, which should give you the same thing. So you end up with 12, let's see, 10, 200, is 240, right? Let's see here. Yeah. So 240, I mean, now we got to kind of have to go fishing for perfect squares. So 240, and I'm just going to do it from experience. If I divide 4 into that, I get 4 times 60, right? And if I divide 4 into 60, I get 4 times 15. So 240 can be simplified to 4 times 15. So the 4 times 4 comes out from the radical as a 4. You multiply it times the 12 to get the 48, and you still have 15 under the radical. So you can do it that way too. They both get you to the right point as long as you don't make any careless mistakes. You just got to, you have larger numbers to work with. And this 240 is like, where do I begin? You can always start parsing out everything by 2. All right, it's another way to do it. Questions on that guy? All right, let me see what else I want to go over with you. All right, let's look at 17, okay? All right, so we're subtracting these guys, just like 16 is a similar approach, right? All right, so I want to get like radical expressions or like terms, all right? Which means I want to get the same values under the radical. Let's just do 16. All right. So 8 times 5, 8 radical 5, I can't simplify any further. So I'm hoping I can get a radical 5 under this guy, and I can at least add the first two. And 5 into 45 goes 9 times. So that's a -3 radical 5, right? -3 radical 5. And if I divide 5 into 80, I get 6. I get 16 times 5. 16 times 5. So we like that. So the 16 will come out as 4, right? So now I've got, if you remember what I said, I got 8 radical 5. I can simplify that. And I got -3 radical 5. Right? And I got minus, what did I say, that was 16 times 5. So that's -4 radical 5. Right? Everybody see where we're going with that? And I end up with my final answer is square root of 5 or 5 under the radical or radical 5. 17 would be done the exact same way. I'll let you do 7. Why don't you just jot 17 down if you want it for practice. Look at simplifying to radical 3 as your combined like terms, what I'm trying to say, or common expressions, all right? Get all these with a radical 3. I don't run out of time. Let me see if I need to go over anything else. All right. Okay, so this is just FOIL, right? And look at this is that complex conjugates. I got -5 and a +5. So I don't even have to do O and I because they're going to zero each other out. So now I've got 1 times 1 is 1, and a negative radical 5 and a times a positive radical 5 is the same as 1 minus 5, right? Or 1 minus the square root of 25. So my answer is going to be negative.
Mr. Gaffney,
Yes, sir.
my mom needs his laptop. Is it okay if I go and I get the last announcements, please?
Yeah, before you go, I'll stop right here real quick and then the others can stay on. All right, give me about 15 minutes after class and there'll be like a 14-question quiz with problems very, very, very similar to what we've just done with a couple bonus questions. So hand copy them, or if you got a printer at home, you can print them out, do those, load them, put them back in Dropbox by 9 a.m. on Wednesday morning. All right, and then we're going to move on to section 6-6 for probably Wednesday and next Monday. Okay.
All right.
All right.
All right, Mr. Gaffney. I'll see you Wednesday.
All right, we'll see you. Okay. Just a couple ones. This you're going to FOIL, but you are going to do the O and I because it's not a complex conjugate like you have here with a negative and positive radical 5. And then this one to solve or simplify, you're going to multiply both the numerator and denominator by 7 plus, this is a complex conjugate, radical 2. Okay. And that's how you would solve it. I'll give you the answer if you want to try to work it out. Let's see here. Let's see, 21 plus 3 radical. It's going to be an answer that doesn't look like an answer that matches that problem, but it's going to be 21 plus 3 radical 2 It doesn't look like this answer goes with that problem over 47. 47 comes from the 7 times 7, which is 49 minus 2. There's the answer that you want to work towards. All right. We got a couple minutes left. I think we've done, maybe 2 of these problems, maybe 3 of these problems, 17, 20, and 21. Any questions on these? Have your little 3 by or 4 by 5, 4 by 4 little sheet of perfect squares, perfect square roots, perfect cubes, perfect cube roots as your guide. As you can see, we use a lot of 25s and 16s and 8s and 4s and 27s. I mean, some of these should be almost mental math now that you can do without even without having to plug them into your calculator or look at your cheat sheet. So I'll give me about 20 minutes and I'll load the quiz on there. Just take it and just put it back in Dropbox by 9 a.m. on, that way I can take a look at it before class on Wednesday, okay? Any questions I can help anybody with? I do have office hours 2 to 2:30, Monday through Thursday, if you run into a snag or problem or have a question, and 9 a.m. to 10 a.m. on Fridays. You guys are quiet. Everybody's quiet. Looks like we lost a few. All right. Any questions before we say hasta la bye-bye?
No, sir.
No, sir.
All right. Just come to office hours if you got any questions.
Yes, sir.
Okay. See you guys. Good couple days. See you on Wednesday.
See you, sir.
Bye, Alex.